Okay, so today we're working on section 3.2, which can be found on page 141. All right, and today we're solving two-step equations. Okay, yesterday we solved one-step equations, right? And this is what solving one-step equations look like. We had addition and subtraction, multiplication and division. And they call it a one-step equation because you literally have to do one thing to get the variable by itself. Here we had to use the subtraction property of equality, the addition, then the multiplication property, and the division property, okay? And that's called inverse operations. Two-step equations means you have to do two things to get the variable by itself. And I drew this big, thick line. It wasn't there yesterday for a reason. Because when you do a two-step equation, you're going to pick one from this category, or these two categories, and one from here. So I may have an addition-division equation, and or an addition-multiplication, or a subtraction-multiplication, or a subtraction-division. You're not going to have an addition-subtraction equation, because that all can be done in one step, okay? So let's talk about what an addition multiplication equation would look like. Here, I'm just starting out with my regular old one-step equation. Whoops. Now, to solve this, you know what to do. You would subtract 7 from both sides, right? And then you would get your answer, and it would be x is equal to 2. All right? But if I wanted to make this a two-step equation, then I would just put a coefficient in front of the x. And now, not only do I have to get rid of a 7, I have to get rid of a 5. Do you see that? The whole point of me getting x by itself, the 2's in the, or the 7's in the way, and the 5 is in the way. So, not only did I have to subtract 7 from both sides, step 2 would be, what do I do now to cancel out that 5? Divide both sides by 5. Do you remember last year me having you write that? Yeah? Okay, so now let's pretend like instead of x equals 2, that 5x equals 2. And that's what I'm going to now just divide both sides by. And I'm glad I did this example because a lot of people think that when they go from this step to putting a final answer, that they have to change it somehow. Like if that was a 12, then yeah, you'd make it 2 and 1 or 2 and 2/5. 2/5 is reduced. It's proper. There's nothing else to do with it. Just leave that as your answer. And I want to point something out here. I wasn't here yesterday to be able to talk about how you show your work, but if you have any less written on your paper than any of these things right here, you will not get your full 5 points. Okay? We have line paper for a reason, right? On that first line on your paper, copy the problem. On the second line on your paper, show that -7. Show your first step. And what you need to understand about equations is what happens on the next line is whatever you did after you cleaned up the previous line, right? So then the next line would be this. Then the next line would be you dividing by 5, and the final line would be your answer. So each of these problems today, unless there's something special about them, should have 1, 2, 3, 4, 5 lines of work. So those of you who came in today that said number 1 was 8, and number 2 was 5, and number 3 was -6, I am not going to give you, I'm going to give you 1 point out of 5 if you have that, okay? I just need you to make sure you understand that. And the reason for that is this, not just because I want you to do more, okay? When you look at an equation like this, what number plus 7 is 9? I know you can do that in your head. I would be concerned if you couldn't. But when you get to equations like 3x minus 2x minus 6 plus 3 is equal to 4 times x minus 9, okay, do that one in your head. I can't even do it in my head, and I'm the teacher, okay? So there's no way to look at that and give me an answer. And the whole point is, if you don't learn the correct procedure now, when you get to problems like that, you're not going to know how to do it. So, trust me, there's a reason for me making you do all these steps, okay? And if you do them, it'll be quick and easy. All right, so that was an addition multiplication. Let's do a subtraction division problem, okay? So let's start out with x minus 5, right? That's a subtraction equation, right? And now let's make it a division subtraction equation. So I just took the variable now and divided it by something. So the first thing I'm going to do to solve this equation is you always want to work backwards because you're undoing what's being done. So order of operations say multiplication and division first. Not when you're solving an equation. You have to do the canceling out the constant first. So I'm going to add 5. What do you think I'm going to do after I add 5 to both sides? What's going to cancel out dividing by a negative 6? Multiplying by a negative 6. Good. So let's do that. So here's line 1. I know the multiplication or the division ones are a little weird, but so add 5, add 5. Done. After you do that, the next line gets what's left. An x over negative 6 is left here, and a 3 plus 5 is 8 is left there. Good so far? Now I want to cancel this out, which means multiply both sides. Here, here, and remember that's really 6 over 1, which is why we're able to cancel it like that, which leaves me with my x by itself, which was the whole point, and a positive 8 times a negative 6, and that's your answer. Now, some of the problems in your homework are going to say solve and then check. Okay, you don't have to show your check, but it's not a bad idea. I've had a few kids after tests come up to me and say, good thing I checked, because my check was wrong. And then it made them, it was a red flag. That made them go back and check their work. So put negative 48 there. What is negative 48 divided by negative 6? Positive 8. And what's positive 8 minus 5? 3. Unless you're pretty sure you didn't make any mistakes, a check is a really good way to go ahead and do that. Okay? Good so far? Some two-step equations may not require you to do one from each category. Like you may have a 7x minus a 4x equals 21, right? So your step 1 here wouldn't be to add, subtract, multiply, or divide anything from both sides. It would be to what? Combine. Go ahead. Yep. So 3x is equal to 21. And then your second step would be to divide by 3. And that would leave you with x equals 7. Good on that? Okay. All right. Then you're going to be given a few word problems. And the cool thing about this book is it always builds on what you already learned. So what did we learn to do in Chapter 1? Translate the output of a function is 3 less than 5 times the input. All right, and we talked before about how this is in English. It's a sentence with capitals and periods and correct grammar and all that good stuff. And math is and this is language. Math is a language too, and I want to translate that, okay? So what I'm going to do is just kind of the output of a function. I'm going to put in parentheses what that would translate to. So first of all, I have to remember what is the output of the function, the x or the y. So think alphabetical order. X comes before y. Input comes before output. So it's input, comma, output, which means the output would be your y and the input is going to be your x. So this tells me, the output of a function, I'm going to write y. What does is tell me to write? Equals. Now be careful. 3 less than does not mean that. That's 3 is less than, okay? This is 3 less than. So 3 less than means this. And remember those of you on your test who kind of had it backwards? I kind of did that more than once, right? It's 3 less than what? 5 times the input. And if the input is x, then 5 times your input is 5x. Okay, look at what we did. The input of a function is 3 less than 5 times the input. Okay? And I know you're looking at that thinking, didn't we already do this? Yes, but there's a second part to it. The second part to this then is once you get your sentence written, it's going to give you further directions. It's going to say, all right, now that you have the correct function written, find your input when your output is, and then they're going to give you an answer or a solution there. So what you need to know to do is, first of all, figure out where 17 goes. Does it go in for x or does it go in for y? Well, what is it? It's the output, which is your y. So let's take this, whoop, and put it right there. And because this is solving a two-step equation section, I'm just going to have 17 equals 5x minus 3. And then you should be able to do like examples 1 and 2 like we did above. So if this was a problem on our homework that we are about to do, I would A, copy the problem. B, I would do my first step. Keep that equation or that balance, that scale. Cancel it out here. What comes on your next line? Whatever results from canceling out that negative 3. What's left? That. What's left here? That. What comes on your next line? Divide by 5. Give that its own separate line. And what comes after that gets canceled out. Your answer. Yeah, it's nice to have the variable on the left. That's what we're used to, but, you know, this is advanced algebra. We should be able to be comfortable with that. Okay? Any questions on that? All right. If not, your homework is going to be page 144, numbers 1 through 23. Just the odds, and make sure you check them. But I also want you to do 24, 25, and 26. Those are just like this. So you have 3 word ones, and then some just straight up equations. Got it?